Algebra of functions. Given two functions f and g, we can combine them using arithmetic operations. Addition, f plus g of x equals f of x plus g of x. Subtraction, f minus g of x equals f of x minus g of x. Multiplication, f times g of x equals f of x times g of x. Division, f over g of x equals f of x over g of x, provided g of x is not 0. And scalar multiplication, c times f of x. The domain of the combined function is the intersection of the individual domains. Let's see this visually. If f of x equals x, shown in blue, and g of x equals x squared, shown in red, then their sum, f plus g of x equals x plus x squared, is shown in green. Watch how the blue and red curves combine to form the green curve. A polynomial function has the form, p of x equals a n x to the n, plus a n minus 1 x to the n minus 1, and so on, down to a 1x plus a 0. The coefficients are real constants. It is a non-negative integer called the degree, and the leading coefficient a n must not be 0. The domain of every polynomial is all real numbers. Degree 0 is constant, degree 1 is linear, degree 2 is quadratic, and degree 3 is cubic. Now watch the shapes of polynomial graphs as the degree increases. A linear polynomial gives a straight line. A quadratic gives a parabola, one turning point. A cubic can have two turning points and crosses the x-axis up to 3 times. A quartic, degree 4, can have up to 3 turning points. Notice the pattern. A polynomial of degree n can have at most n minus 1 turning points and at most n real roots. Remember this key rule. A polynomial of degree n has at most n minus 1 turning points and at most n real zeros.